Okay, we'll go ahead and get started now. So, um, I guess the first thing I would like to say is that for the extra credit opportunity, um, the uh, the Lubos Paso live stream was actually last Saturday. In case you missed it, you can still catch the recording of it and watch that so that you can still get extra credit. Um, well, I would have to find the link somewhere. Yeah, and I'll post the link in the chat so that you guys can watch it. All right, I just put the link in the chat. Remember, this video is just part one of the performance. Part two is next Saturday at 7:30, and you need to watch both parts and then make a little write up in order for you to get extra credit. All the details are in the email that I sent before. But anyways, so that covers the extra credit. So the next thing we need to talk about is the week 11 sections. Was there any parts in here that you guys had trouble with? We could look at it and then work on it together before we move on to the lab, because I did unhide one lab today, and that's this one, parsing dates. How do you feel about the sections? Are we good on the sections? Okay. So if everyone's good on the sections, we can move on. So I understand that there's two things that we gotta do today. The first thing we gotta do is this lab here. But the second thing we gotta do is look at the homework, because last meeting we started looking at problem 3, I believe, of the homework, and I actually did work on that over the weekend, and I would like to show my finished work to you guys, and that's okay. So what do you guys want to do first? Do you want to look at the homework first, or do you want to do the lab first? Homework, then the lab? Okay. Can someone post the link to the homework again? Because I actually bookmarked it before, but it wouldn't let me access it because I guess the link expired. So if someone could repost the, all right, perfect. Thank you, Logan James Ashbaugh. Okay, so this is the problem that we started before, right? It says define an employee structure with a name employee and an employee pointer to the employee's manager. For the CEO, that pointer will be null pointer, right? Write a program that defines several employees and their managers. For each employee, print the chain of superiors. Hint, create a helper function to assign every employee with their name and their supervisor. You can use dynamic memory allocation within the helper function. Okay, so we worked on this a little bit before, but we ran out of time. But if you guys want to see what my code is for this, so this is the code that I was working on over the weekend, right? So last time we took this linked list function and we were just modifying it to say employee string name and employee manager, right? So if you recall from the last meeting, we were just working things around, and we took some functions from the linked list class that we grabbed from Zybooks, but from the last meeting, I did add a couple new member functions. These constructors we already had. We kept the get next function. These were two functions that I just wrote myself because I figured that we're going to need it in the program. In case you're picking up from our last meeting before. So I wrote two new member functions. This one is of type string, which returns the name, right? And this one sets the pointer manager to whatever memory address we send to this function, okay? So if you go back to, let me put this here and here. So this says write a program that's define several employees and their managers. For each employee, print the chain of superiors. Okay, so I'm gonna here. So I hope you guys can see this. So I made a very normal example here. That's where because the program just simply says make a bunch of employees and define their managers. Okay, so I decided to arbitrarily make up a bunch of employees, like this guy Alex. I called him the CEO, and then the two people under him are Billy and Carly, right? And then both of them are pointing to Alex because he's the CEO, right? Right? And then if you look in this diagram, Billy is the manager of Daniel and Ethan, and Carly is the manager of Frank. Right? So I just completely decided to make that up. So in this program, I said I did exactly what the instructions tell us to. Just write a bunch of employees, like Alex, Billy, Carly, Daniel, Ethan, Frank. And after that, I just, using this set manager function I made, the argument that it takes is the address of the manager that it needs to point to, right? So I simply said, hey, because employee 2, Billy, his manager is Alex, the CEO, who's employee 1. I'll just say employee 2, who's Billy. I will set their manager to be employee 1, right? And I have to have the address of operator because set manager accepts a pointer, right? And then next I said Carly, who's employee 3, her manager is Alex, who's employee 1. So I'll simply say employee 3 dot set manager employee 1 again, right? Slayman Toki says, so it's one main.cpp and one header. Yes, it is one main.cpp and one header. So if you were around in the last meeting, you may have recalled that we stole this linked list class from one of the Zybooks, and we just changed things around to conform it to our problem. Like we changed linked list to employee and whatnot. I just decided to finish writing it over the weekend so that we're not spending too much time in this meeting doing it. That's all I did. So if you were in the last class meeting, you had all of this already, except for these two new member functions here that I wrote. Well, if you were around in the last meeting, right? But anyways, moving on. So because I said that employee 4 and employee 5, who are Daniel and Ethan, their manager is Billy, who's employee 2. I just said employee 4 set manager employee 2, employee 5 set manager employee 2. And then lastly, Frank, who's employee 6, their manager is Carly, who's employee 3. So I simply said employee 6 set manager employee 3. Okay. But lastly, what we needed to do was for each employee, print the chain of superiors, right? And that's actually the reason why I wrote this this print function here. So what this print function does is it's called print chain of command, and it takes a pointer to employee. I named it LL, which stood for a linked list because it made sense to me. And I simply said, see out chain of command of this pointer dot get name. This is me using the get name function that I wrote, right? And then while the node that we're looking at is pointing to dot get next, if you recall, get next is the function that moves us to the manager, right? While it's not pointing to null, we will see out current node dot print employee data, and then we will get next again. So we move on to the next manager if there is one, right? And then I also had to do this. I had to print one more time because this while loop would not catch Alex, the CEO, because they're pointing to nothing, right? So the while loop would stop because Alex is pointing to null. And that's why I had to iterate once more. But if you wanted to see this working, here's what I got. So this is, so line 42, where I said print chain of command of employee 1. Employee 1 is Alex, remember? So I said chain of command of Alex, the CEO, and it just lists their name and nobody else because there's nobody above them, right? When we move on to, when we print the chain of command for employee 2 is Billy, right? So it printed their name, and then it printed Alex's name next because they are their manager, right? And then employee 3 is Carly, so it printed Carly's name, and then Alex, who is their boss. And then Daniel, his chain of superiors is longer. He's managed by Billy and then Alex. That's why you see Daniel, then Billy, then Alex. I think you guys get the picture, right? But this is the solution that I came up with over the weekend. If you guys would like to see this code, I will show it to you here. But also, if anyone else came up with their own solution, you're more than welcome to share it with the rest of us. Because I'm a little bit curious to see how anyone else may have done this. So here it is. So this is the main.cpp. This is the header file that we all created together, right? Keep in mind that you don't have to use my example either. You can make up a completely different chain of command with a much larger tree than this if you wanted to, and just define what their names are here. Yeah, I put a comment here that says define employees, and then you set their managers here, and then you can still print the chain of command and see what the hierarchy of command is. So, so before we move on from this question, was there anyone else that that made up their own solution, and they would like to share it? Okay, I guess not. Okay, so does this make sense to you guys? Do you guys have any questions?
Yeah, so at the get name function, you're wait, no wait, not the get name function, not the it's in the print chain of command function.
Yeah.
You have on line 8, no 9.
Yes.
Yeah, so you're having the reference. So you have to have you have to have it as a reference. No, dereferencing.
Yeah.
The LL. Yeah.
Yeah. I called it LL just because it stood for linked list.
Yeah, but like when you oh, so using the could you have used current node as the could you use current node dot get name? Would that have worked too?
Do you mean like this? Like this?
Yeah.
Yeah, you could.
Okay.
I believe this.
Okay. But then it has to use the
yeah, it makes that difference.
The pointer operator, right?
Yeah.
Okay.
So if you ever dereference pointers, you could do it 2 ways. You could do it like this, or you could do it like that, or like this. But either way, it's the same. Yeah, let me fix that. Slayman Toki asked in the chat, and you stole this code from the week 10 lab. I think I stole this code from the week 9 lab, actually. Let me double check. It's not here. I believe it's here. I think it was week 9, right? Oh, wait. Oh, no, you were right. It was the week 10 lab. Yeah, I was too lazy to write my own linked list, so I stole this thing here and just modified it. Yeah. Yeah, I changed this to employee, change this to name. Well, you guys can see it here. Like I'll scroll down slowly in case you guys. Well, this is being recorded, so you guys can always watch the recording. And just as a basic exercise, if you are gonna use this solution, one thing that you should try is instead of using my little example here, because I made this up on the fly. Maybe you should make your own employees and set their own managers, right? And then see how that works out.
Oh wait, so that function you defined it in main. Shouldn't that be in the header file? I think it works. It will work either way, but like, would that usually go in the header file?
Oh, you mean this one?
Yeah.
Oh, I just decided to put this in the main function.
But it could go in the header file, right?
Yeah, you could. And then if you put this in the header function, what would happen is that this function becomes a member function of employee.h, which means that in order for you to call this, instead of calling it like this, you would call it like this, employee one dot print chain of command, like that. But I didn't I didn't do it. I didn't put it in the header file. I put it in the main file, which is why I have to call it like this. But you could do it that way if you wanted to. Okay, so that's problem 3. Does anyone have any more questions in regards to this code? No? Okay. Does anyone else need to see it, to still see it?
Yeah, because I see the print chain command.
Yeah. Okay. There you go. Okay, perfect. Okay, so if everyone is good on the code, we can move on. I'll just minimize this for now. Close this. What was this? Okay. So going back to the Xi books, so week 11 material is going to be due 5 o'clock on Tuesday. So we have to finish a lab today so that you can turn it in before our next class meeting. So so one thing that I noticed about these sections is that as we progress, the amount of work that goes into one lab is getting progressively more and more difficult. And I actually looked at all of these, and a lot of these labs require a lot of work, but I decided to just unhide one lab for you guys, just because I looked at this one and I think this one lab is reasonable enough for you guys. Okay, so let's do this lab together. 11.9, and if we have time after we finish doing this lab, we can continue looking at more homework problems, because the homework's not due until the 29th, right? So you still have we'll still have more time for me to help you before then, but this lab is going to be due before the next class meeting, so we better do this one first. Okay, so does everyone have 11.9 open, parsing dates? Okay, perfect. So 11.9 lab says parsing dates. So our job here is to complete the main function to read dates from the inputs, one date per line, right? So there's one date here, so on and so forth. Each date's format must be as follows, where you have the month, followed by a space, and followed by the day, followed by a comma, followed by a space, and then the year, right? Any date not following that format is incorrect and should be ignored. Use the substring function to parse the string and extract the dates. The input ends with with a -1 on a line alone. Output each correct dates in the following format, where we convert the month to its corresponding integer value, followed by a backslash, followed by the date, followed by another backslash, and then followed by the year, right? So for example, if our input is this, we have March 1st, 1990, April 2nd, 1995, this. The output is going to be 3/1/1990, and then 12/13/2003. And the reason for that is because the only two dates in our inputs that followed the correct format was this one and this one, right? That means that these other two entries are ignored. And then we finish it off with a -1 to indicate that we've finished reading the entire input file. Okay. So the nice thing about this lab is that it already came with a helper function. So this helper function called date parser accepts a string called month and returns an integer value, which is its corresponding month. So if the month was equal to January, we will return 1. If it was equal to February, we'll return 2. If it was equal to March, we would return 3, and so on. And if we encountered a month that didn't fit this format, it would just return 0, right? Does that make sense? Okay, so, this is actually very similar to one of the homework problems if you look over here. So, yeah, so it's actually very similar to this one. See? So instead of breaking a string down into month, day, year, problem 5 on your homework requires you to break a string down into city, state, zip. So if you actually, if we do this lab successfully, you probably would have enough knowledge to be able to do problem 5 on your own, right? Because the principle is the same. We're breaking down a string into its constituent parts, right? So pay good attention on this lab, and then if you do, you might be able to do problem 5 on your own. Okay. So here's what we're gonna do. So to do read dates from input, parse the dates to find the one in the correct format, and then output month, day, year formats. Okay. So the way I see it, we're gonna continue reading lines until we see a -1. So here's what I say. I say we're gonna need a while loop, right? And we're gonna continue get lining the inputs until we read a -1. And the moment we read a -1, then we stop. Okay. Do you guys agree with that? Yeah. Okay. So so if we're getting this inputs, I think we're gonna say while I say we're gonna have a string variable that contains the line, and then we'll put that in our while loop. So let's define a string called line. And then we're gonna say get line. lowercase I, cin, and whatever line we retrieve, we'll put that into our string line. Okay. So so if we ran this line of code, what line would be equal to is this right here. And then after this, we're gonna make our while loop, right? So while. So as I said before, we would continue parsing until the line that we retrieve becomes until line becomes equal to -1. So I'm gonna say while line does not equal the string -1, we will do something, right? So this is going to be the part where we parse our line. And this is going to be the part where we get the next line. So I'm going to put a comment here, and I'm going to say, we're actually going to use this line again. Okay. So the very first thing we do is get the first line. And if line was equal to -1, this while loop actually wouldn't happen at all, right? Because this instantly became false, so we skip over this. Yeah, I should really have a return here. Let me do that. But if this line was not equal to -1, like say it was equal to this, then we'll parse it and then get the next line. The next line will be April 2nd, 1995. We'll parse it and then get the next line. The next line is this, parse it, get the next line, this, parse it, get the next line. And then when we get to -1, that's when we know when to stop, right? Does everyone agree with this code so far? Okay. So now we have to write the code that allows us to parse our line. So if it was in this format, we would output the date, right? But if it wasn't in this format, we wouldn't output anything. So in order for this to work, there was actually a function from one of the previous sections that allowed us to do optional outputs. And I believe it was called I say C++. I believe it's string. So end positions. Here's what we're gonna do. We're gonna have an if statement here. So we will know if we'll know that our months are in the correct formats if we find a comma between the day and the year. Okay, so here's what I'm going to say. If I'm going to say so so here's what I'm going to say. We know that the date is in the correct format if we find a comma between the month, the day and the year, right? So here's what I'm going to say. The find function returns a substring, right? So does everyone know how the find function works, or do I need to go over that? Okay, so for those that may have not done the sections yet, the find function is a function that belongs to the string library. The string library. And what this does is that it returns an integer value that's equal to the position in the string. In this case, the string is line, where it finds the substring where it equals comma, right? So if we did this on the first line here, this would return an integer value where it finds the position comma, right? So if this is 0, 1, 2, 3, 4, 5, 6, 7, this would be equal to 7, right? However, if it turns out that there is no substring this in line at all, what would happen is that this function here would return no position of string, right? And that was actually a thing that I was looking up earlier. So if you were trying to find a substring in this string, but couldn't find it, it would return this value here, right? So this gives us the power to give outputs for this and this, but not for this and this. Does that make sense? I know that this is a lot. Anyways.
Does the find function have a string parameter or a character parameter?
A string, as you can
Okay.
see with the double quotes.
Okay.
Yeah. Anyways, so I should make a comment here. Gives us the okay, so moving on. So now we need to start. We should take the line and start breaking it down into its constituent parts, right? So here's what we're gonna do. Since we know that this is in line right now. What we need to do is retrieve the substring up until we see the first blank space. Like, so we'll traverse every character like in the line until we see the blank space, and then we'll say, okay, everything that came before the blank space, that will be our month, right? So here's what I'm gonna do. I think we have to define a couple new variables here. So over here, I'm gonna say we're gonna need a string, which we'll call month. Then we need to find we also need the day, and we also need the year, right? So I'm gonna say I'm gonna have another string for day, right? And then I guess I'll have another string for year, right? So now that we have this, I guess we should initialize these. Okay, so now that we have this, I guess the very first thing we gotta do is find the month, right? Now, there was a really useful function in the sections that allowed us to retrieve a substring from the string that we're looking at, right? Does anyone remember what it was? It was called substring. Like, so I'm gonna say month equals line dot sub, like that. So substring requires 2 arguments. Okay, so the first argument needs to be the position where the substring starts, so an int value, and the second argument needs to be an int position where the substring ends, right? So given line, where does the month start? Well, that's kind of an easy question. We know that the month always starts at position 0, right? So our first argument for the substring function is going to be 0. But then we also need to find the position where the month ends. But lucky for us, we already know another function that allows us to return an int value where we can find a substring, right? It's the find function. So I say month is going to be equal to the substring starting at 0, and we'll stop where we see a space. So I'm going to say, for the second argument, we will say line dot find and this needs to be parentheses 2. So if line was equal to this, the find function with space would retrieve the int value 5. So it goes 0, 1, 2, 3, 4, and then stop at 5. If it was December like this, the position of the space would be 10. So it would go 0, 1, 2, 3, 4, 5, 6, 7. December has 8 letters, so it'd be 9. So it would retrieve everything up to here before the space and everything up to here before the space. Okay, so we know that this line here will give us the month, right? So now that we got that, now that we have that, one thing that would be useful for us, now that we retrieved the month, one thing that we could do is erase every character that contained the month and the space, so that we don't have to, so that the remaining line would be this or this, and we don't have to deal with this anymore. So here's what we're gonna do. After this line, we'll say line dot erase. Now erase is another function that belongs to the string library. It requires 2 arguments as well. The first argument being the position where you want to start erasing. So in our case, that's going to be 0. And then lastly, the second argument needs to be the integer position where we want to stop erasing. So we're probably going to say find again, right? But now here's the thing. Having find by itself allowed us to get this, but ignore the space. But we want to delete the space as well, right? So here's what we're going to do. Since this whole thing returns an integer value, but we also want to delete the space as well, I'm going to say +1 here. So if I didn't have this +1 here, what would happen is that March would be deleted, but not this space. And then I would be left with this. But because I also want to delete the space, I'll say find +1 so that I'm left with this. Okay. Okay, so I guess the very next thing we have to do is, so now that we have month, the next thing we got to do is get the day. So now our string variable looks like this, right? Or this. So what do we have to do now in order to retrieve the date? We know that the date is in the beginning of line now, but how do we know when to stop? Well, we would know when to stop when we see the comma, right? Back when we were doing month, we know when to stop when we see a space. But now that we're retrieving the day, we know when to stop when we see the comma. So I think in order for us to get the day, it's actually going to be very similar to this line here. So I'm going to say day equals, and this is a string, by the way. We're going to copy this line here. But instead of stopping when we see the space, we're going to stop when we see the comma. So I'm going to replace this empty space here with a comma. Okay. So that will give us our day string, right? So because of that, I guess a convenient thing to do next would be to erase everything up to that. That's that again, right? So I'm actually gonna copy this line here and replace this space with a comma, so that everything up to the comma would be deleted, right? But I actually don't want to just delete this. I want to also delete the space that goes after the comma too. So if we ran this code the way it was now, this would erase everything up to here or here. But I want to delete the space that comes after. So I guess instead of saying find +1, I guess I'll say find +2. That would allow me to delete everything up to there, right? Anyone have any questions so far? Okay. So the last thing I have to do is, now that I have the month, oh, Logan James Asbot says, why not erase up to the space and then add 1? That's a good question. Would that actually work? If you erase up to the space and then add 1? I suppose that could work. Arturo Perez says, would that work with double digits per day as well? Yeah, it would work for double digits because we're retrieving everything up to the comma. If line was equal to this or this, we would just retrieve everything up to the comma. So it would work for double digits. And that's actually the reason why I couldn't just say substring from 0 to 1, because what if the day is double digits instead of 1 digit? That's why I did it like that. But back to Logan James Ashbach's question. Could we do this and just say +1? We could do that. I think so. All right. We're gonna we're gonna do it your way, Logan James Ashbach. All right. So so now we have month equal to something. Now we have day equal to something, right? The last thing we need to do is set year equal to something. But there's some good news for us. If we deleted this, if we deleted all this, and we deleted all this, all that we're left with is the year, right? So whatever remains of line, we're gonna set that equal to year. So we're gonna say year equals line, like that. So I think that would work. So I'm gonna have a comment here called that says parse month, day, and so now that we have this, month is initialized, day is initialized, year is initialized. All that's left now is to output it in the correct formats. This. And this is actually where my helper function comes in. You see, my month is going to be equal to January, February, March, April in string form, right? What I need to do is convert that to its numeric form. And that's where this helper function comes in, right? So here's what we're gonna do. I'm gonna make a new comment here. Output correct. So because we need to output it like this, we're gonna take our month string and feed it into our helper function, date parser. So we're gonna say cout. This function was called date parser, right? So I'm gonna say date parser is D capitalized or no? Oh, it is capitalized. I'll just like that. And date parser requires one argument, that argument being the string. So I'm gonna pass month into it. And that should work, right? The next thing I need to see out is a backslash. So I'm gonna see out backslash. And then the next thing we need to see out is the day, which is in variable day already. So backslash. And then lastly, I'm gonna output the year. Okay. Now, quick question. Does this require us to end the line after our format? Well, we're doing multiple lines, so yeah, we are gonna have to end lines. So here is the breakdown of our code. We have a while loop that will continue doing this until we see -1. This if statement here allows us to ignore days that don't match the format that we're looking for. To get the month, we'll set it equal to the substring between 0 and then where we find our first space. And then we'll erase everything that wasn't the substring. Then day will be equal to everything up until we see the comma. Then we'll erase everything up until we see the space and then go one further so that we can delete everything up before the year. And then we'll set year equal to line, and then we'll see out this. And then we'll continue doing that until we encounter -1. Let's try this and see if it works. It works. So let's look at some of these examples and understand what's happening. So
can you check on mine? There's something wrong with the spaces.
Sure. I'll help you in a moment. Let's just
Okay.
look at this a little bit. So our for loop ignored these two and just converted these. That's why we see 3, 1, 1990, and then 12, 13, 2003. For this input, the only ones that are in the correct format is these two and this one. So we ignored this one. And so that's why we outputted these and outputted this. So here's the code here. So our code is all of this. Okay. Does anyone have any questions about how the code works? If not, I'll just go on to helping Miss Valerie Mora.
Actually, I don't need help because I just fixed it. It was like the double quotes thing. There wasn't a space in between them, and then I put it in and fixed it.
Oh yeah, are you talking about these double quotes here?
Yeah, because one of them were just like jammed together, and that's why it didn't work. But as soon as I put a space, it worked.
Yeah. That's actually how the find function works. It retrieves an int value equal to when it sees the substring. But if you don't have a substring, there's nothing to look for. So you don't have an integer value to return. That's why. Okay, so you don't need help anymore?
No, I'm good.
Okay, great. Does anyone else need help, or does anyone have any questions about the code in general? You could use this code to help you do question 5 of your homework. So you can say that the string city is everything up until you see the comma, right? And then you delete everything plus the space, and then for the state, you delete everything up until actually no, that wouldn't work because you can't delete everything up until you see the space, because what if you have a state that has a space between like North Dakota or South Dakota? And instead, at this point, you would just say the last 5 characters of this string call that the zip, delete that, and then whatever's left, that's your state name. That's how you do it. But one thing that's also different between this lab and this question here is that instead of retrieving the input in the form of an input like this, like you get from the console, you would actually get your input in the form of you would actually have to pass the string into a function instead of doing it this way. But that, I don't think that's that really hard to work around. But as always, I will be here to help you guys in case you guys need help in any of the other questions. Now, we are at time here, but that's okay. We got a lot done. We finished problem 3, and we did the lab that's gonna be due 5 p.m. at Thursday. Once again, here's the code. This recording will be up on Blackboard directly after this meeting. Any other questions before? Any other questions that need to be addressed? Okay. If not, so on our next class meeting, what I know that you guys are gonna have questions on the homework again. Which homework problem should we start looking at before on our next meeting? What do you guys say? Or does maybe you guys haven't really looked at the homework yet, so you don't know which questions to ask? Oh, we have. So all we did was question 3. Question 1 and question 2 are extremely similar to each other. Question 5 is similar to the lab that we did just now. And then 4 is for first-name characters. Which problem do you guys want to look at for the next meeting so that I'm prepared next meeting? You guys want to look at question 5 on our next meeting? Oh, 4? You want to look at question 4?
I'm thinking 4, yeah.
You're thinking 4? Yeah, Arturo Perez in the chat says 4. Okay, so on our next meeting on Thursday, we'll start looking at question 4, as well as doing the week 12 sections, or starting it at least. Okay, so if no one has any other questions, we could wrap up this meeting here. And I'll see you guys on Thursday. All right. Later, guys.